Welcome everyone to this week's CLM. Hope everyone had a great 4th of July break. We are back this week with Shari Weaver, who is a new PhD student presenting. Master's?
Yes.
New student presenting, so great
student.
jumping in, and I'll let her, if you want to introduce yourself and give a little background real quick, and then we'll jump in.
All right, now where do I look at people?
Just normally.
Normally.
The camera's right up there at the top. But,
So my name is Shari Weaver, and I just started the program in January, so I'm brand spanking new. This is my first project that I'm working on, and it has just been, this paper has been accepted at a conference, so I'm really looking forward to getting some feedback. Outside of my life as a graduate student, I'm the director of teacher preparation here at WPI, which is a very small program in which students here major in science, engineering, mathematics, and then also participate in my program, and they become certified teachers in Massachusetts. So we're a very small program, but we turn out the largest number of physics teachers in the state, which sounds impressive, but it's usually 1 or 2 a year. Still the largest number in the state.
A record is a record.
A record is a record. And we like to say that we produce more physics teachers than MIT, but sometimes. And then before that, before working here at WPI, I was a high school physics and biology teacher. So that's my frame of reference. And you will see that that's what drives my work that I'm going to present today. So I'm just going to jump in, but please feel free to stop and interrupt me at any time, ask clarifying questions. Because the K-12 system is my world, I sometimes assume knowledge. Because it's been my world for so long.
If you could give us guidance to start of what kind of feedback you're looking for, or any specific questions that we should keep in our mind as we go through this.
Yeah, and you'll actually see that later in the presentation as well, a reminder of that. But what I'm looking for are a couple of things. You're going to see something that I applied to the K-12 system that characterizes that system, and I'm going to need some feedback in terms of, am I missing anything? Does it make sense to someone who's not from the K-12 community? And then I'm also looking for some feedback on what type of interview questions I can ask to get the data that I'm looking for. So I'm going to be taking data in August with a group of schools, so school systems. And so I'm just starting out in that process. And then if there's time, while I haven't modeled this work yet, I am starting to think about how to model it. And so that would be helpful. Like, where do I even start? And luckily at the SD conference, George Richardson and I happened to be sitting at the same table for dinner, and he gave me a little bit of advice, which was good, but I could definitely use more. So, so what I'm presenting is the paper that I've written is using a service science canvas to understand institutional change in a public school system. And so I'm going to talk a little bit about what that is. I actually have the canvas in front of me, although it's particularly tiny, and you'll see it as well. And so the problem is that I'm addressing is that over the last decade, since the writing of this book, Rising Above the Gathering Storm, which kind of cried out this need for STEM professionals, and so great attention has been given to this need over the last, since 2007, to improve STEM education in the United States. And because of that, and there have been many, many papers since that time, financial resources have been dedicated to this. I mean, millions and billions of dollars from NSF, from private corporations, and even school districts have reconfigured their budgets. They've gone out looking for grants as well to improve the quality of STEM education in their school. But what I have seen, I've experienced personally, as well as looking around at schools that I've been connected with, is that there's been very little change. And actually what little change there has been is not sustainable. For example, faculty might be given a grant to work with some teachers. The teachers do some work, they implement some things, they take some data. The minute the money runs out, teachers revert back. And that's just what happens. That also is true with school systems as well. And so in that, I realized that this is a systemic problem, and it has to be addressed at the system level. Now, at the STEM Education Center where I work, we have a program called the STEM Integration for Education Leaders. This is a program where education leaders in districts, they apply to be in the program. They're in the program for a year. They come to our center and they work with our staff and with each other to develop goals and a vision and a plan to implement STEM in their district. And what I've noticed in the 6 years that I've seen this program is that all districts experience some change, but some districts experience tremendous change, and some districts experience only minimal change and impact by being a part of this program.
Can I ask a question about the STEM education problem? When you are telling about STEM education problem, what specific problem are you pointing to?
Yeah, thank you for asking that question. So usually, if that book kind of outlines, and then again, many papers since then, is the issue is that we have this developing technical workforce, and we don't have the students coming through the universities who are majoring in STEM. And some of the people that come here from other countries, they may major in STEM here, but then they leave and they don't enter the STEM workforce. And even in times of really great recessions, like the one we were just in not all that long ago, while other jobs were declining, jobs, especially here in Massachusetts, were increasing in terms of in STEM specifically. And so again, not in all areas of STEM, but certainly in specific areas, particularly computer science and certain types of engineering. Computer science is probably the biggest need that we see. This is also true even in education. The #1 greatest need for educators, for STEM educators, is physics by far. I just went to a conference recently where they said we need to produce 1,400 physics teachers, new physics teachers a year, and we're only producing 600. So this is why when I talk to my students and I say, if you want to be a physics teacher, you can pick your state, you can pick your town, and you will have a job. It's
And
very
this
easy to get
is
a job.
generally in the high school and middle school level, or does this also include college?
High school and middle school level, mainly. I don't actually know for the university. I hadn't thought about that. That's a good question. Does that answer your question?
Yeah, so it is increasing the number of students who enter STEM, higher education, and also STEM careers. Yes.
And I do have data around that. If you're ever interested in it, I have the data on other slides that I have when I present to teachers. So when I go into districts, and I start when we're first starting, like the district in Texas, I start with the why STEM. Why do we do this? Why is this important? And I have all of the stats to back up why we're spending the time and energy to do this.
So I can comment. I'm friends with a lot of Thai scholars, and a lot of them are in math science, of course.
Mm-hmm.
One of my best friends, he's a PhD in physics, and he says it's actually very hard for them to go back if they're in physics because there are too many.
In their own country. So it's better to stay here if they can.
But the problem is their contract, their Thai scholars, the government paid for them to come here, they have to pay back that
Right.
amount of money. Maybe double or triple
Right.
on their scholarship.
Yeah, that's really interesting. So, and you're correct that in other countries, this doesn't seem to be as problematic as it is here. And again, from the teacher perspective, what I know of being in the K-12 world, in many school districts, up until recently, there was zero, and in my town, I can actually say this, there was zero science education until the 5th grade. I mean, absolutely nothing. Not a science class, not a science activity from grade kindergarten to grade 5. Now, why did it start in grade 5? Anybody guess? Why did they start teaching in grade 5?
That's when I got a teacher that could do it.
No.
I sent my
No,
coach
that's
physics background.
That's actually the grade that the students are first tested in their tests. It's grade 5.
I was thinking when my first STEM class was, it probably wasn't until 7th grade.
Oh yeah. But we're now realizing, and I think I have realized this being a parent as well, that kids can do STEM earlier. And for some students, they need to do it. They need to have that exploratory, technical, scientific exposure pretty early on.
May have another slide. So
Sure.
I went to Catholic school. We started in the 3rd grade. This is in Lawrence.
Mm-hmm.
Lawrence is my hometown.
Right.
We also used to have a Seton Asian Center where they would teach the ones going to 1st grade because I was one of the volunteers and I was in the math and science and we were teaching them going into the 1st grade. These are all Asian students. but then that center closed. Apparently they don't offer that summer program anymore, so I'm very curious about this.
Right. No, definitely. And like I said, it continues to be an issue. You know, I think we've made a little bit of headway, but not nearly the headway that we need to. And so in thinking about how to approach this, I started by thinking about how to characterize the system as a whole. And so what I decided to do, again with Oleg's advice, is to use service science and to use the service science canvas, which I'll share with you in a few moments, to initially characterize the district. And so for those of you who don't know what service science is, because I did not know what that was until I started, again, writing this paper and thinking about this work, is that it's a system it's a discipline that studies systems and value co-creation. And so what I put forward in my paper is that schools are service systems, that there is this exchange that occurs between individuals in the system, both within and outside of the system, and that there is a valuable exchange. And that exchange can be, you know, intellect or knowledge or experience.
In economics, we call that supply and demand.
Supply and demand, right? And so there's this exchange of beneficial action, which is knowledge and experience. And I would venture to say it's not just teacher to student, but it's also student to teacher as well. There is a mutual exchange of ideas. And that there's this active participation of provider and customer. And so we can think of the provider as schools, administrators, and teachers, and then the customers as students, parents, and community. Although I would also venture to say that teachers are also customers in this system as well. And so the people in this field that kind of started this out proposed 10 principles that are used to understand a service system. And so I used that to apply a service science canvas to analyze the school system. And this was developed by Oleg and Frank Foy. And they used it to analyze entrepreneurship here at WPI. I took their system and applied it to a pre-K-12 environment. And my goal was to characterize that system. And then once I characterize that system, to take data, which I'm going to start in August, because we have our new districts that start in August. So I'm going to take data in August. After they've gone through the program for a year, I'm going to take data again in May. And then I'm going to take data a year out to look at not just change, but sustainability of that change. And then my goal is to, once I have this model and I have that canvas, I can take this out to any school system and advise school leadership teams when they're implementing new initiatives. Of course, my passion is STEM, so those are the schools. That's what I'm probably going to target.
One of the things you had asked is how to go about modeling this and sort of think about it. One thing you might do that is as you go through this, especially with CLTs, because they're fairly easy, but just as practice for your own techniques, when you encounter these interesting things, like you said, some schools do really well, some do poorly, or you describe this nature of why do students only get STEM education at 5th grade. Make small little CLDs of everything you find, and you're basically assembling a case library, as it were, in something you're passionate about, but will also help you practice just thinking and building these. And as you build these, I think you're going to get a library of these, and some of them are going to be crap. I mean, it's just the nature of doing it. But that practice will help you get better, but it will also help identify the pieces. So when you're ready to say, I want to build a model, you can say, I want to put these 4 or 5 together, but not these 6 over here, or, you know, help you think about that.
And I'll give you an example of a couple I've already thought of and written down. Is there's the reinforcing loop. So when I go to work with teachers, particularly in the younger grades, they often don't teach them because that wasn't their background, so
Right.
they don't have confidence. And so when I go, and I'm usually working with them, not just on pedagogy, but also on content, science content. And so there's the reinforcing loop of providing support and training, and then increasing teacher efficacy.
Right.
And so that can be a reinforcing loop. However, what I've also seen is there's another loop in which teachers burn out. Because, and I'll hear this phrase, oh, this is the newest thing coming down the pike. which apparently is a phrase not just here in Massachusetts, but anywhere there is a pike. They say
It's like anywhere in business, it's coming down the pike.
Coming down the pike. I actually asked them in New Jersey, when I was working in New Jersey, I'm like, is that a phrase that you use here? And like, oh yeah, because we have the New Jersey Turnpike. I'm like, okay. And so teachers are used to so many initiatives that are not supported, and then die out.
It's like with the weekends.
Yeah, so they burn out. They put a lot of energy into stuff, and then administration changes, or the focus of the school changes, or the school board changes, and it's all going
That would be great too.
Yeah. So I don't even know if that would be called burnout. It would just level coming down the pike frustration, for lack of a better word.
Traffic jam on the pike.
Yeah. Yes. And so I'll hear that quite often. They'll say, "Oh, okay, so this is just the newest, greatest thing." And so often we have to go in and convince them that what we're teaching them will transcend their leadership team. Although sometimes I wonder if that's even true.
Which is in terms of system dynamics modeling, and I suppose it could port over to other sorts of modeling agent-based learning. Jay Forrester, our founder, always advocated that a system dynamics model should not be sort of, it starts off, if you will, as a case study, a very specific instance, but then it rises a level higher to either, we would say, a generic structure, or the inductive, we study philosophy of science, so we go from a pattern model to a real typology, where there's the similarities among different individual cases yield a sort of a generic set of feedback, in our case, feedback loops, stocks, and flows, or what have you. So when he did his urban dynamics book, very famous book, it was a Boston. But it was not Boston dynamics, it was urban dynamics. Even though he had all of Boston officials helping him, domain experts, in the end, it was a model of a city, not of Boston. And he said, if you properly parameterize your dynamics model for any city, it should work. Similarly, Jack Homer, a friend and colleague of ours, was interested in the fusion of medical technologies into the marketplace. How does this happen? It was a bit unusual because physicians had an enormous impact on what the patient received as a therapy, as opposed to you pick your own car or what have you. And he selected two very different medical technologies, cardiac pacemakers, a physical device, and clindamycin, an antibiotic. And his model, with like 5 changes to it, a couple of table functions and whatever, could mimic or explain these two very different medical technologies, very different time shapes and what have you. So I think if you're going to go the modeling route, this is sort of the pre-modeling, brainstorming aspect to it. I think you want to orient your mind, if you're going to use at least system dynamics, to the notion of you're going to create a model not of your school district, but of a school district. And here are the circumstances under which STEM thrives and is sustainable, and then here's the circumstances under which it's not.
Right.
And finding those leverage points in the system where, like in Jack's model, 5 places where it could really change the time shapes but mimic another specific instance, right? Well, that's good to know as to where do you press and push on the system. The other thing, so this is teeing up for a classic system dynamics thing. You're describing chapter 1 of John Sterman's book called Policy Bed and Policy Resistance.
Right.
So why do policymakers hammer on systems, push them as hard as they can with time, people, money? Been a war on poverty since the 1960s. Do we still have poverty? Yes. After trillions of dollars, how come? And in system dynamics, we have explanations for this, but it's a classic issue of policy resistance. All this money from the feds or whatever comes in, we need STEM, we have to compete in a world economy, blah, blah, blah. And you get some traction until the money runs out or whatever, and then it goes right back to you push the beach ball down under the pool, you let it go. When the funding runs away, it goes right back to where it was. Classic system dynamics. So in my opinion, my advice to you would be to orient your mind that way, and that you're doing sort of the preliminary mental model mapping, brainstorming, what have you, that is crucial to the creation of such a model. You can't start with the model, you gotta start with this.
Right.
this
No,
this here.
that's such a great point. And actually, I'm hoping that by characterizing these 3 new districts, which will be very different from each other, because typically my coworker tries to get a wide range, and actually not just public school, but also private school, Montessori schools, etc. That I'm hoping I will get that kind of range of what this model will look like. And so starting with characterizing the system, but actually bringing it to, it would also be interesting, I think once I think about modeling STEM initiatives, if I could bring that even to a more general level of policy implementation in a school system, regardless of what it is, that would actually be helpful. In fact, at this conference I just went to, the SB conference for Creative Learning Exchange, there was a whole district there from Utah, and they came to the conference. I think they were looking for someone to help them think about their school system and how to affect change. I don't know that they were thinking about how to do it in a high school classroom. I think they were really looking for people to help them analyze their school system to more effectively push through what they were trying to push through.
Yeah, one other thing, not to monopolize the conversation, but another place for you to look, I think, that would be profitable would be to look at Peter Senge's work on learning organizations and his book, The Fifth Discipline.
So yeah, that's actually what got me started in system dynamics or systems thinking a long time ago. And I'm sure I told you all this story of I was in a seminary class called Urban Ministry. It was Urban Ministry Systems. And one textbook was The Cat and the Toaster by our professor, which is the systems of how to look, I don't know, it's an interesting book, like how to look at ministry through systems. But the other book was Peter Senge, Fifth Discipline. And it was in that class, in that moment that we were supposed to be learning about urban ministry, and I was, but I absolutely applied it to the school. And I realized, oh, this is why this is going on. This is why there's a level of frustration. This is why. It was very interesting.
I think there's a lot of, to a quick sidebar, are you willing to present the paper you wrote on pattern models, typologies, and principles, like in September, get an actual CLM dedicated to that? Because I learned a ton from that paper on how to organize thinking of how to create small models as cases or pattern models and then combine them. So just if you're willing to do that in September, standalone presentation on it.
No problem, because I think this is important for all the students to sort of think this way, maybe.
It's a great
Consider
methodological.
thinking this way.
Yeah.
And so to complete the point, so Peter's whole framework of making a school district, if you will, into a learning organization. The broader question is implementing model-based results. Okay, I've done all the proper best practice modeling and background information, what have you, and I've got it. I know what to do. Now, how do I get a school district to do it and do it consistently, sustainably, and all that? And that's very, otherwise it's just an academic exercise, and you get your credential, and the thing goes on the shelf in the library and gathers dust, and that's that. So among the things that are useful is then turning the model you create into a game. And there's various ways of doing that, but gaming is very powerful. So instead of putting a PowerPoint presentation up to all the teachers and officials in the school district and saying, I've done all this research, blah, 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 here's these 7 bullet points, do them.
Right.
Okay, and here's a bunch of citations that show I'm right.
Right.
That's just sort of the traditional academic way of doing stuff. Better, we found, is to turn your model into a game. It's fun, it's engaging, and those 7 bullet points are discovered by the people when they play the game. And the light bulb goes on in their mind. Very powerful way of conveying these sorts of insights. And that's not the only thing you got to do, but that's one way to think about, okay, I want to really change, I don't want to just do this like for a dissertation to get a credential. I also want to make a contribution. You should consider bringing gaming into your research.
I think it's a fantastic idea, because typically in any school district, like the one that I'll be working in extensively, I get 1 day, I get 6 hours with the school administration. That's all you get. So you need to have you have to get a lot out of that 6 hours. And I think a game like that, beer/Bible distribution game.
I love how it was the Bible distribution.
Bible
game.
In seminary.
In seminary.
We got the Kool-Aid
That's it.
game at high school.
That's what we had to, yeah, that's how we do it in seminary, Bible distribution. But doing something like that was impactful. I mean, so much so that I remember it however many years later. So I think you're right about that, turning that somehow, bringing this into a game and having them experience.
Yeah. And we've learned a lot how to do that in system dynamics well, and what like works and doesn't work. But also we have an interactive media and gaming program here at WPI, which, to be honest with you, we haven't really tapped into those folks like we probably should have. And realistically, the way it's going to happen is we'll send a graduate student emissary over there with a white flag and say.
And luckily, every year I had students that go through my program that are IMT students.
Yeah, right.
I actually have one that's working on it, just finished last year.
But the gaming folks know about how you make games engaging. I mean, that's their point. They'll say, "Oh, people get bored with every single game. You name the game, they get bored with Monopoly or whatever." But the key is to make it a long time before people get bored.
Right.
They have to get to level 73 before they finally get bored, and then they use it a lot.
Right.
I love playing The Sims as a kid.
Right.
I still play it.
Yeah.
I'm old enough to remember Sim Earth back in the DOS.
Do you remember SimCity?
I do.
That is
I
based
was
off
addicted.
Urban
Dynamics.
Absolutely addicted.
That's what I didn't realize. It was based off the Urban Dynamics model, so it uses Jay Forster's model as an engine. What a great
And
way.
we actually talked about that at this conference, and I said, I wonder if Sim Earth is also, no one else is.
I don't know, does it have technology or not?
Yeah. No one else in the room knew what Sim Earth was. I said, oh gosh.
I'll play it.
You'll have to look it up. So as I said before, so if you can kind of just take a peek at these element components, because I'm going to be presenting this at a conference to people who are not in the K-12 community at all. I will probably be the only K-12 person there. So I wanted to make sense to someone who's not in that world. Also, when we think about some interviewing questions, and then you've already given me some great advice about how to begin modeling, so that's fantastic. So here's the canvas that I just took Oleg and Frank's canvas and applied it to a STEM system. And I'm actually going to just focus on a few because our time is short. And so here's the canvas as a whole for those of you who can't see the paper. And so these are the 10 principles of systems. And then what I did is I just took those 10 principles and thought about what does this look like in terms of a pre-K-12 public school system. I say public school here because the governance is, although you don't see it here, it's written in the paper, is specific to public schools. Public schools have a very different
So
governance.
the bold top at each box, that's the principle coming from service science?
Yeah, so these are the principles, the 10 of them.
Are those principles or just names?
Principles, elements,
Interesting.
they're called a couple of different things, aspects.
Structure of the system.
Structure
Yeah,
of
it
the
seems like a
system.
structured way to go about looking at something, as opposed to
Right.
a principle being do this or follow
Right.
this.
Right. I've actually heard it called principle, factor, quality, yeah, element. I actually like the word element. That makes more sense
Yeah.
to me. So that's the word I actually
Being
use.
the physics background.
Yeah, you know.
So when we do, we're supposed to just interject.
Yeah,
this week, okay?
absolutely.
So
please.
when we do at least system dynamics, not agent-based, that's a little different. When we do system dynamics model, we typically say that we're not modeling the system. We're modeling a problem from a systems perspective. Big difference. When you try and model the system, everything, including the kitchen sink, goes into the model because it's part of the system.
Right.
Whereas if you're modeling a problem or a curiosity, a question, then you're going to leave things out of the model that exist in the real system but aren't germane to the problem, and that allows one to simplify.
Right.
So you can think of drawing a fence around your model. If it's outside the fence, it's in the real system, but it's not part of the model because it's not relevant to the problem.
Right.
If it's inside the fence, it's deemed crucial to understanding the problem to which the model is. So John Sturman, one of our esteemed friends and colleagues, wrote the current Bible of System Dynamics. We always say, Rookie modelers ask, what can I put in my model?
Right.
Veteran modelers ask, what can I keep out of my model?
Right.
So this strikes me as more of a systems, like everything that's relevant to the system, as opposed to a problem. I would imagine you're going to find it's a subset of that stuff
Right.
that's going to constitute your model. And then the key question is, well, what subset of stuff? You know, for example, back to the urban dynamics model, Forrester, who lived in Concord, Massachusetts, a suburb of Boston, left the suburbs out of this urban dynamics model. He was widely criticized for that. He's like, look, I understand cities and suburbs, I live in one.
Right.
It was not important to the problem I was on.
Exactly.
I mean, so many people complain, you might have a master's student add the suburbs, and didn't change it. But,
Sorry to interrupt. Can you give an example of like a system modeling versus a problem modeling? Like if we have one or two.
well, I guess following up on the urban dynamics thing, Forrester wondered why cities were very attractive places to move to in the early phases of their life cycle. So population growth was exponential. Everybody wants to go there. Then the rate of growth would reduce, peak, and then they became unattractive places to live, and people were leaving. Well, why is that? And so the question was, what's important to making the model do that? And he said the suburbs, though they're part of the real system, are not necessary to explain this population behavior. And he left out other stuff too, but that is one concrete.
Well, and I think you can use this as an example too. So this will describe the entire system, but I've already started thinking about, but not all of these pieces are crucial to the question that I'm asking.
Mhm.
And so I've already thought about, and need some help thinking about which pieces are crucial to the problem. And I think that's where my desire to take data comes from, because if I can compare schools and think about what's different between one school and the other, then I can get at what are the key ideas. I mean, I have a thought of what these things are. If I were to just decide these are the pieces I'm going to focus on, I would most likely focus on stakeholders, value co-creation, networks, and resources. That's where I would focus. So, but that's my gut response based on my own experience. I actually don't have data to back that up yet.
Okay, so pressing the preceding comments further.
Yeah.
So the way we begin typically a system dynamics modeling project is to state the problem, question, curiosity, whatever it is, in words. Sometimes that takes 7 seconds, sometimes it takes 7 days. If you have a group of experts and stakeholders that can't agree that the table is oval, let alone, what the problem is, or, why am I here to help you with modeling? And other times it's, everybody's cool with it. They all simultaneously ask the question, what's the problem? They all simultaneously say it's no big deal. But you want to be able to state the problem in words. A good sort of research dissertation mindset is ask a question, answer a question.
Mm-hmm.
And do that 3 times for 3 papers, and you got a doctoral dissertation.
Right.
So what's the question you're going to ask and answer, and you're using this particular tool system. But then what we do is we translate the written, verbally stated question or problem into what we call a reference node. And this would be a time shape representing the problematic behavior to which the model will be addressed. And the base run of the model will mimic that problematic behavior. And then you can use the model to run experiments to say, well, what if we do this? Does it change those time shapes in a good way? Then you have to start defining what does better mean, what does solve mean. A lot of times this is not easy. I do something in 550 with heroin addiction, and crime rates going up when the police seize the heroin. It drives the price of heroin up, and you get heroin-related crime going up. So the reward is fighting crime is more crime.
But doctors work.
But right. I think there's a lot of generic. But here's the thing: you ask the question. So what's important to the problem statement or the reference mode? Well, are you the police chief? Are you the mayor? Are you running the methadone clinic? That person, any one of those people deems important, might be different from the next person's. Who's the client? So it's not like there's the answer 7, and we're just waiting for you to discover that. I mean, it depends, right? So,
You had a statement on something like that?
but again, this would be, I'm trying to set the tone of the mindset that one would use in system dynamics anyway. How you go about your business. And without we found without a concrete statement of what is the model directed towards, you get gargantuan models that are hard to understand and aren't terribly insightful. And
why do you think there isn't a standard format of what I would call a charter, which is sort of like all these things that go into it, your problem statement, your perspective, your audience or boundary, those things that are sort of like, these are things regardless of model, your stakeholders, time, that you should probably get an agreement on before you start. It may be a living document, but it's sort of like, it would be very similar to agent-based modeling, ODO or ODIS, that initial. Why is there nothing in system where someone just said, this may not be universal and people may dislike it, but here's a start,
There's a little bit of that, and that's somewhat what the research we're trying to get some doctoral students to do is what's the best practice that's teachable, repeatable. And if you do all these steps, they don't have to be linear, they can be iterative. You can go circle back but at the end, you'll probably, if you do these steps correctly, have a decent model.
Right, it seems like 90% of it's technique and 0 on the method of doing a project of model.
Yeah, and here again with who's the client, it's not like if you do all these steps, you'll get the right answer, the right model.
Yeah.
7 people can do it, and there can be 7 different correct models at the end because they emphasize different things given the client or the experts who help them or what have you. So
and that's a really interesting
it's messy.
because even thinking about my particular question or problem, and we're looking at how can we effectively implement STEM initiatives in a pre-K-12 school, right? If that's the question, and why doesn't it happen, right? If I'm contracted by the superintendent who wants me to talk to her school leaders, she has a certain level of, a certain perspective, and so how I would model this for her would look different than how I would model it for the school.
Yeah, when we're working with the military, there were 3 levels. There was tactical, which is what your units do on the streets and how they act. There was regional, that you're in charge of a theater or region. And then there's strategic, which is the world. And I can see education, like there could be tactical things to increase STEM at the class. But if you're modeling for the president's education budget or the new education czar, that's a budget in dollars and budget. I mean, it's a whole different world. So I think doing a lot of models, a lot of little ones, as a sort of an exploratory exercise and using that to build your always be building to your dissertation, but do a lot of exploration along the way. Rafat and Saeed have a great sort of life cycle of a PhD that says, here's your exploration stage, here's your variation stage, here's your consolidation, and here's your production.
Here's your despair stage.
Do you guys Rafat and Saeed, are you guys able to present something on that in September? There's a couple of classics that I think are worth presenting at the start of every school year. This pattern model one, maybe slicing by Professor Saeed, your guys' stuff on the PhD. As we get new students in, it's sort of like, here's some good refresher ones for all of us to look at. Rafat, Saeed, are you guys able to present in September?
I think we should. We're supposed to present something. Yeah, we submitted actually the paper to a conference.
Okay, great.
But I think we can share it definitely.
Yeah, you got to do a CLM. Yep. Have you also ever heard of 5 whys? Like WHY? Why? It's a very simple exercise that I teach in process engineering to people who are like leagues dumber than system dynamics. But it's the question of why do we not have STEM, right? Then you get an answer, and then why does that answer? And then why does that answer? And then why does that answer? And I think for a lot of your models, you're going to be modeling at the 4th or 5th why. The first why we don't have STEM, is going to be a problem that is the universe big.
Right.
And drilling down to something very concrete will actually make the modeling much easier, much able to say, I'm answering a specific problem. And then as you start assembling those or looking at them, you may have something to say, this is how I go to a bigger one.
Did Ann have something? Ann Johnson have something like that at that webinar? It was similar to that with where you ask these whys or whatever.
Yeah.
Technique for
lots of, basically, you just keep going deeper, deeper, deeper,
Right.
and to get to something that is small enough to handle.
No, for sure. I mean, again, this is a huge problem. So definitely narrowing down, and that's why, like, starting with the characterization of the system,
Yeah.
and presenting that and thinking about that, taking tons of data from different school sets, and then starting the model. The modeling is probably a year out for me right now. Although, like you,
I would
you
challenge
have
maybe maybe try some modeling without data or with limited data.
Okay.
Because sometimes the data it depends, can really bog you down. There's tons of data in the world. Very little of it actually, it's sort of like an iterative back and forth approach. When you have your data and you build a model from data, you realize the data is not connected. It's missing huge gaps. You kind of like, no one ever studied this, so how do these things connect together? And because no one's ever looked at it as a system, they just go out and have. Plus, data itself by its nature is sort of, it's a model that is always wrong, but it could be useful because it's just an abstraction of reality. A simulation is a model that's wrong, but could be useful. And the way you use that is to sort of guide, maybe this is the data we need to be looking for as opposed to what we're collecting. This is a high leverage point or this is an insight. And there's no data on that. So it's sort of use them back and forth because.
When collecting data is not a bad idea, whether it's numerical, survey,
this
or
is
whatever.
Oh, mental models.
So talking to experts, whatever, that's perfectly good to do. However, at this point, I would ask you, you mentioned you'd like to see STEM initiatives being sustainable in school district. That would be kind of the solve, if the problem were solved.
Correct.
So what does that mean? More specifically, could you draw on a graph of time on the horizontal axis? What does that mean? Would you be able to do that?
And for those who are online, we're testing our new camera.
You want to strike hard in the fear of a doctoral student.
I know, like,
and an oral exam, you'd say, go to the board.
Well, and what's interesting, so again, having dinner with George Richardson, that's what
real quick, if you're online, click on Christine's window and it's pointed to the whiteboard.
But that's what George had said over dinner. Is he said, because I said, listen, what do I even do? You know, I'm just starting out. He said, behavior return graphs. Just draw it.
We also had a comment I don't want to lose from Diana Fisher. Welcome, Diana. Thanks for joining us. Who mentioned starting to build a model may also help focus what data you need to collect. So, thanks, Diana.
So, if I were modeling, let's see, students entering STEM fields from high school, right? Which we can, I mean, again, so this would be data from like 11th and 12th graders, right? And so where it is, you know, again, if I were to just draw this, it's probably pretty steady for the most part. It doesn't go up, it doesn't go down, it just kind of is what it is, but it's low. And so, so again, if we have kind of that implementation here, assuming that implementation can happen immediately, which of course it can't. So what we're hoping to see is obviously growth. And then there's the expected. And then of course, what we don't want to see, right? What is that called? I don't know. So
is there a scenario where it goes down? Like a disaster where it actually declines? Or is that just unrealistic?
I don't think it will decline.
Okay.
I think it's already so low that I don't think it will decline.
So and how would you, so then how would you measure?
How would we measure?
That line that you're drawing is measured how? What are the units of measurement? You have time on the horizontal axis. The vertical axis is what units of measurement?
Oh, this is number of students entering STEM.
Per year?
Sure. And yeah, per year.
Okay, so it's a flow. Because we deal with stocks and flows. So then the next natural question would be, so where is it flowing to? Flows flow to, have you had any system?
I have.
Okay, so flows always flow to
Stock.
Stocks. So what's the stock to which that flow is flowing? So you get a twofer. So you identified something that's important to the problem.
Right.
You've identified its time shape, including better, the same, worse.
Right, yeah.
But you get a twofer. Now, if it's a flow, you know it has to be flowing to a stock. So then what would be the stock? Or outside of it could be a cloud.
So yeah, so the stock would be, I don't know, maybe I would say, well, the unit would be students, and it would be in STEM and undergrad, right?
Okay.
Right.
Sure. So, or if that was not relevant Sturman in chapter 5 of his book talks about challenging the clouds. I mean, it could be a stock or a cloud. It could just float out of the fence, a hole in the fence, and go outside of your system because it's not relevant to what you're modeling.
But if you put an arrow into that, which is your number of students entering STEM, right, your stock, what's the outflow then of that stock?
Oh, well, there could be an outflow of students graduating and going into STEM.
Right, that's a good outflow.
So that is workforce, right?
Yeah.
Or what also happens often, unfortunately, particularly with underrepresented and minority
This is
students
what I'm
and
getting to,
females,
yeah.
is they leave.
And that
So
goes to a cloud of something.
They change majors.
Yeah.
They become humanities majors.
So-
or whatever.
So this would be, we're not going to solve this right here today, but this would be the sort of mindset to adopt in terms of building a system dynamics model of this particular, well, any problem, but this
Right.
particular problem. You'd be saying, all right, I'm not going to include everything here. I'm going to include only the relevant stuff to my problem statement. What's my laundry list of relevant variables, factors, elements, whatever you want to call them? What are their time shapes? When you say time, we haven't defined time as months, years, whatever. How many? That axis there, that's 40 years, 4 years, 400 years, whatever. And then is something that from your list of important stuff is a stock or a flow or something else, but looking for stocks and flows. And if you've got a stock, it's probably being changed by a flow or flows. That triggers more stuff.
Right.
If it's a flow, it's got to flow somewhere.
Right.
And pretty
And this
soon you
is
begin to.
Right, and this is actually what I would consider an outcome. If you look at this is an outcome. So where the issue also lies is here, is the implementation. And so this is a huge interest of mine, is thinking about when teachers, why is it that teachers are successful or not successful in implementing STEM in their schools.
Yeah.
And so that becomes another behavior over time graph, although it wouldn't look like this necessarily, because I think there's generally an increase, but then there's a sharp decline. And that's what happens.
Yeah, when we talk about policy resistance and system dynamics, we kind of say that most complex feedback systems tend to exhibit policy resistance.
Right.
One of the main explanations for why it happens is misalignment of goals. So negative feedback loops, balancing loops, if you will, are goal seeking. They have a target. So the bathtubs, there's a desired amount of stuff in the bathtubs, either defined by a person or nature or what have you, or what's normal, what have you. And in the case of policy resistance, what you tend to see is that the people implementing the policy have different goals, different targets than the people receiving the policy. So the policy makers are pulling like crazy in this direction, that's their goal, and everybody else is pulling this way because their goals are misaligned.
Absolutely.
And then, so you might be able to get, in the near term, the policymakers to get the system to go this way, but eventually everybody grabs on the rope and pulls it back the way they want it to be.
And I
Because
think
their
that's
incentives
where
are
the
different.
value co-creation comes in my idea, that kind of bringing teachers on board and seeing a collective vision, if that makes sense. And so I see that as kind of that value co-creation.
Yeah, if you impose from the mountaintop something on people down below without their input, they tend to
What
resist.
happens. Exactly.
And that right there, the policy resistance points in a system dynamics model are the most important ones to identify, and I can almost guarantee there's probably no empirical data because people are looking at, stocks. They're measuring what can we measure and count, and there's going to be tons of data on this, but this sort of why is there resistance? There may be no data, or it may be you're going to get it from mental models, like why does implementation not
That's
work?
right. Talking to people who live and work in the
I
system.
should differentiate between numerical data and mental model data, but I think this is why I'm nervous
and
about
even when I say data, I'm really talking about interviews and surveys.
That data is
physically visiting schools and
that's a great approach.
Oh, absolutely. So when I say data, that's
Okay, I thought you were thinking like statistics and
No.
data science and all, which is useful, but it's
useful, but it doesn't get at the heart of it, right? And like I said, luckily I've been through it as a teacher and as a teacher leader, so I've seen it and I've been experiencing it. And so now I'm just trying to model what I know or what I've seen, but I want to make sure that I'm not just one voice, that this is what I'm, again, with all the experiences I've had with other districts and teachers and just tons of people you talk to about this. So, but that's a good point.
Yeah, it's interesting looking at this. There's like 30 stocks and 6 flows.
Oh yeah.
But I think the key point is don't try and model everything on this page.
No.
But some people do that. Like even, I don't know, the standard method has always confused me because the standard method encourages the first step is brainstorm a whole bunch of variables. And then the second step is really good. It says throw most of those out and only focus on a few. But it sort of like gets people the mindset of thinking about the system as all this stuff and gets their brain primed for.
And actually, in reality, when I'm working with district leaders, if I presented this as an entire model, there's no way. I mean, they just can't take that all in. I can't take that all in. So finding out what are the key places of leverage and focusing on those, I think would be helpful. At least that's what I'm hoping.
Yeah, another sort of mindset thing I have found to be helpful. Although the more we do this sort of thing, it's going to be less helpful because we're orienting the graduate students from day one properly. But I used to ask at a dissertation proposal exam to the student, in one sentence, tell me what you're going to do. And almost invariably, nobody can do it. They give you 2 pages of, well, here's one, and 75 minutes later, they've completed explaining what they're going to do. And then I'll tell them, you need to tell me and be able to tell me in one sentence what you're going to do, and you're not focused enough.
Okay.
And then I tell them, at your dissertation defense, I'm going to ask you, again, in one sentence, tell me what you've done. And if you can't do it, I will not vote to pass you. Because I want them focus. Boil it down. Ask a question, answer a question. Or if it's a 3-paper dissertation, ask 3 questions, answer 3 questions.
Right.
Right. Now, maybe it's 2 sentences instead of 1, but I think you take the point. You've got to, semicolon. But you want to. A lot of people think of dissertations as this magnum opus. This is my doctoral dissertation. It's really typically a person's first research effort, not their magnum opus, career-ending memoirs and everything. And so. The 50th time you do something, it's better than the first time you try to do something, right? So it should be, you got to bring people in from, I'm going to do this wonderful, thing to get my official PhD credential, to ask a question, answer a question. It's as simple as that. And you might know that already, but I can't emphasize enough that that's perhaps what I've found over the years to be the biggest sticking block for people getting it.
It looks like the share has, up on the up top where the red button stops sharing.
Oh.
Yeah, click on that and then reshare it again. Give the share green, just to disappear.
Oh, wrong one. Okay.
There we go.
No, that's a great point. And actually, I'll be honest that all of this work comes from a desire to practically apply anything that I come up with to help district leaders think about this, because they're asking these questions and they need us, they need system dynamicists to come in and help them think about the system, and they're looking for it. But because they've tried these little piecemeal approaches that haven't worked. Because it's the structure of the system as a whole that's a problem. And that structure generally involves leadership, resources, and stakeholders.
Do you have latent structures on your schedule for classes? 5, 6, I think, or the latent, it's system numbers. I don't remember the number, but it's a latent structures of systems.
I don't.
And it's a very good, I wouldn't take it immediately. I would take it after you've had some fundamentals, but it gets into policy resistance and the latent aspects of the systems that drive policy resistance. So it's another way of talking about what causes policy resistance, although oftentimes it's not even as immediate as sort of policy holders don't understand that there's something that's fundamentally driving it. There's like 8 different types of latent structures they go over that would be probably very useful. Good, so we've got 5 minutes left. I want to give you the last word. Any final questions, any slide you have to get to? We can always do this again. The great thing with CLM is we can do multiple iterations.
Well, certainly, if you guys have this, if you look at it, if there's anything that's going to make sense, shoot me an email, because again, I will be presenting this in November to a group of people who are not educators. And so But
So
they are service scientists.
Yeah, this kind of represents sort of a sectoral diagram, you would say in system dynamics, that broadly your model is going to have like 10 sectors or whatever.
Right.
And then within the sector, there's a bunch of stock flow feedback loop stuff happening, and then the sectors are going to be interconnected. Something like that, I guess, in terms of. So by all means, don't throw this out. This is very good.
Well,
But,
and actually, I think where at some point, I don't know if I got to this. Network. Oh, I didn't put it. Oh, I did. Here's what I struggle with: the value co-creation, because I actually think that's going to be an important part of the model. I think that's good. I think that's key. I think that's key to the whole structure of the school system implementing any kind of policy change. But this idea of value co-creation is very new to me, so I don't even know the language in order to ask questions.
The word value, so lean systems is all about value add and doing value. What I have found in 20 years of doing that is that the word value itself is such an abstract concept that you have to have a framework to give someone a definition of what value, what the characteristics are, but then talk to them and sort of pull out in an interview style. And you're going to have to tease out what the actual values are.
Yeah.
Because a lot of times people are giving you what I think I like or what is manifested or explicit, but what I really value is a little deeper.
Right.
And if you're dealing with different communities and different cultures, like I went over to Belgium as the worst experience I ever had, trying to translate what value was from an American concept to even a Dutch concept was like night and day. So as you go with different communities, the concept of value, in some communities it might be security, which has nothing to do with STEM. I mean, you sort of like, and you're gonna have to bring them on track. What do you find value in STEM? It might be, I don't find any value in STEM. It might be something totally different.
And
especially when you get to these different, like,
these different groups.
value of faculty, I still have a job.
Right, right.
A career stability, that's my value.
And how do you even, I probably will not focus on students. I don't know, maybe I will at some point. But how do you even help students express what they value? Although I would say I think high schoolers are underrepresented in these conversations. I think they have a lot to add to what, and I think they have some thoughts around what they value in their education.
Lots of interviews will help here because your first couple will probably reframe the way you're talking and asking, and then the next 10 will help you really.
Yeah.
Are you going to do segmentation at all to say, look, we're finding within parents there's 3 or 5 different personas of parent. Here's the highly active mom that attends all the PTA, donates to this, and this is the value statement for her. This is the split couple family and the values for them, and sort of create big segments of value.
Well, I will say this for in terms of the modeling, I'm not going to include parents at all.
Okay.
Because they're outside of
Well, that's
what I
easy
think is the issue. Yeah, parents are. I'm actually going to focus mainly on the faculty, the school district, and the community, because I think that's where the issue lies. Quite honestly, I think students can add to that, but that will be.
Yeah, well, the more generic problem is overcoming resistance to change,
Right.
which is, I mean, it's way beyond just STEM. I made that point
That's what
earlier.
I'm saying, yeah.
So I think there's a lot of merit to. I mean, this thing could go in a lot of different directions beyond just the STEM.
And actually, even faculty, community, and school, I could actually leave out the community and faculty, school students too. So it kind of depends on the focus. And even as I go back and think about networks, I think this is actually key as well. So this will be included in my model. I'm pretty sure.
In addition to thinking about interview questions, one of the things when modeling this comes from Forrester seminars is think of the perspective you're modeling from.
Okay.
So when you're creating a model, and he uses this in the context of the business, and the example he gave is I could have modeled this business from the perspective of a worker, from the perspective of a manager, or the perspective of an investment banker. And he chose investment banker for the problem at hand. He said this is the right, and so his perspective in creating that model was what is of interest to that perspective in the model. So the investment banker doesn't care about a lot of details that the worker would care about. And when you're talking about something as huge as public education, you might have several models built from, yeah, there's someone with a dog that's in the background. You might have different models with different perspectives, kind of like these cases or pattern models that say, here is a school from the perspective of a student, here's a school from the perspective of its faculty. It's a way of also keeping your model small,
Right.
rather than trying to combine a bunch of different perspectives in one.
That's a good point.
The other thing that's triggering in my mind is we're really knocking on the door of evolutionary systems, whether it's Hegel, antithesis,
Dialectic.
synthesis, or the institutional economist, the ceremonial way of doing things, the traditional way, and then the technological change, and you get the fight between the people who want to do it the old way and the new way. And then there's some kind of consensus or whatever, but it's really not necessarily revolution, because you said it doesn't happen, but it's an evolutionary process where the system starts to evolve towards a more STEM-centric.
Or whatever the policy is.
Because what's your time? I gotta imagine this is like a 20-year time horizon from let's just say Common Core, right? From the dash line of start implementation. When do you see results? 10 years later? 5 years later?
Well, and that's a really great question. So the case study that I did for the paper is a pre-K to 3 school, grade 3 school. So we're not going to see, and they had huge success in this STEM implementation, which is why I started with that. But we're not going to see the benefit of that. We're not going to see the results of that for, even the 3rd graders, that's 9 years. That's 10 years. So
I think that's a huge area to focus on, because a lot of policy people are like, we put all this focus and we're not seeing results. Yeah. 9 years is 2 presidential administrations. You're talking about a time of.
And that's actually part of the problem.
Yeah.
Quite honestly, because by the time you start to see change, you have a change in administration. I worked at one school for 5 years.
It's not working. We haven't seen any benefit. We're going to cancel.
But I worked at one school for 5 years, and we changed administrations 4 out of those 5 years. So when you're in a system that's varying like that, and every new administration comes in with their own focus, and so that's where the teachers get the next thing coming down the pipe. Let's see what this administrator wants. So that is part of the issue. And of course, it's also, thinking about school boards, which run schools.
Mm-hmm.
The town, at least in Massachusetts, that's how it works. Not how it works everywhere. The school boards and the towns run the school. The school boards, 3 to 5 years is how long they serve on school board. So again, the time frame, I think, is actually a huge problem.
We are at the top of the hour. Any last questions from folks in the field? Remotely, we're going to turn off the recording and we'll still be online, but I just want to check before we. Any other questions?
No, it's just excited saying here's how it's working.
All right, thanks everyone for joining. We've got a couple more of these. Professor Saeed is doing a presentation. I think Tapra is doing a presentation. If there's an open slot, I'll take one for Iceland. But remember, we are dark in August, and we'll be back in September. So thanks everyone for coming back again. Hope everyone had a good 4th. I'm going to stop recording now.